Hello, my name is Reese Allen, and I'm reviewing the public lecture that was on the 2020 Nobel Peace Prize in Physics. So, why did I attend the lecture? This lecture interested me on a level at which I had relatively no experience or knowledge in the field. I wanted to get the chance to learn and understand something that I never thought I'd have the chance to learn. So, a basis of the Physics Nobel Peace Prize that was given out this year is that there were three individuals: Roger Penrose, who got half of the award, and Reinhard Genzel and Andrea Ghez. They each got a quarter. So first up is a background on Roger Penrose. Penrose had an interesting past as he had trouble in his early career understanding equations in school. However, he bested this obstacle by rewriting equations with his geometric graphics. It helped him understand key concepts, and he hoped others would benefit with it as well. And by the age of 27, he took his first physics course, but really didn't get involved in anything until he met David Finkelstein. Finkelstein gave a public lecture on black holes and the horizon, and Penrose immediately wanted to collaborate with him. They ended up collaborating the rest of their lives, giving each other feedback back and forth, and this led Penrose to investigate general relativity of spinors. This theory on general relativity was disbelieved by many physicists at the time, but are the basis of today's discovery on the black hole. So at 33, Penrose began studying topology, which is the study of surfaces, and made a profound statement on gravitation, which robustly led to black hole singularities. This was another discovery that influenced today's discovery, but was also very disbelieved by scientists in the era. And then by 38, Penrose began working with Stephen Hawking, and they concluded that gravitational collapse was a major cause in black holes, and that a body bag type object allowed you to see the surroundings of the black hole after things were trapped inside. And one main theory of Penrose is that quantum mechanics was wrong and that they don't correspond to classic mechanics. Later in life, Penrose began using his knowledge toward books that he wrote. And one of them was The Emperor's New Mind, which was a neuroscience-based book about the human mind and how it was not able to be graphed by a computer system, and it was non-algorithmic. And another book was The Road to Reality, which highlighted Penrose's findings about the universe and how black holes function in space. So shifting into the modern era, we have two scientists, Genzel and Ghez, and not just them in general, but many other scientists built off of Penrose's developments and formulas, and were able to use them for calculations that led to black holes and how they function around other stars. And so Genzel and Gez's background was they're both physicists, and they were looking for answers about black holes. And they started about the 90s, and Genzel was from Germany, and Ghez was from UCLA in California. And they both wanted to probe into space and search for proof that black holes were in existence. These two physicists were able to develop a way to witness star movement through advanced optics dating back to the 90s. However, in the early 2000s, there was a breakthrough which allowed it to be even easier, as adaptive optics reduced blur that occurred from the luminescence of stars and black holes, which made it much easier to see movement, and they could make observations based on that. They found that several stars were making elliptical orbits around an object that had a very large mass, 4.2 million times the sun, with a radius of 13 million kilometers, which isn't very much. And that was an extraordinary finding, because no star could fit this description without collapsing on itself, leaving one obvious answer: a black hole. So why were these physicists given this honor? These physicists were awarded the Nobel Peace Prize for that discovery. On one hand, Penrose created the general relativity and space formulas that were used later in calculation, and Ghez and Genzel built on these formulas and actually physically discovered the phenomenon physically. Without Penrose, it would not have been possible. All three physicists played a major role in the discovery and are deserving of their reward in their relative means. So I took a lot away from this lecture, in that I never knew much about black holes, so this lecture showed me that there was math behind it, and why something that has always been once deemed as imaginary could now and is now becoming a reality. I never heard of these people, and based on who they are, their diverse backgrounds, they greatly reflect on the work that was accomplished. I learned that even some basic physics principles can be used on a complex scale, and even I can go make an impact using what I know now. Some things I already knew going into lecture was that I knew some basic understanding that a black hole had been discovered, but I really didn't understand what it meant or what it could lead to in the future and how big of a finding it was. I also had heard of the book The Road to Reality, written by Penrose, as it had been recommended to me before. So what sparked my curiosity in this was actually Penrose's past. Although this doesn't relate a ton to the topic at hand, it does motivate me to try and make a difference. Many people, and many times I feel like, don't know enough to venture out and research and understand concepts, but looking at Penrose, who didn't even take a physics course until he was 27, proves to me that I can do anything I set my mind to. I just must have the willpower to learn and be brave enough to believe in something even though others may not. So in general, this subject doesn't really entirely relate to mechanical engineering, which is my major, but the story does. In my major, discoveries are found that change the whole dynamic and can revolutionize the way things are built and manufactured. So even though I'm not exploring space and making discoveries there, I will be discovering more efficient processes, which can always happen. I did make a follow-up on the topic after the lecture. I dove into the black hole findings, and I wanted to see who made the most of discoveries and how they're putting it into the work in the future and what they're looking for now. My big question that relates to black holes and what happens to them and what happens to objects that collapse in them. It is yet to be answered, and one day it will. Thank you.